Okay. Looks like we're live, except on fucking YouTube. It's like slow as fuck. Right. This looks good. Okay. I'll read it later. It's been a while since I checked out Hacker News. Excuse me. Excuse me. Not sure why, but it only happens when I'm streaming. Fucking throat gets all itchy. Right, okay. I'm hoping to be able to write some code today, provided I understand something. Right, okay, the first instructions. Yeah, I'm not sure I really understood this. The architecture is some single biggest influence. Yep. Build a stack machine. Yeah, I read that. Later on. Yeah, we gotta keep track of where stuff is. Fair enough. Tell the VM add these. Okay. Oh, so the stack only holds data, and you go through the instructions. Fascinating. Okay. Yeah. Starting with bytes. Right, first bytecode instruction. Yeah, I'm not sure I understood this bit either. Since creating definitions while programming is not much more than telling the computer what we know. What do we know about bytecode? What was bytecode again? Was it the push stuff? No, you mean the actual byte? Bytecode. Oh yeah, it's the one. Okay. We're off to a good start. You know that it's made up of instructions. Right, okay, now I know. So it's got, what we know is we've got an action and something to perform that action on. As far as I understand. And if there is no something, we just get it from the stack. And we know that the instructions themselves are a series of bytes, and a single instruction consists of an opcode and an optional number of operands. Right, close enough. An opcode is exactly 1 byte wide, has an arbitrary but unique value, and is the first byte in the instruction. Right. Looks like we know quite a lot, and the best thing is that this is precise enough to be turned into code, literally. Okay. And since I guess for... I hear a dog outside. Yeah, we know... Do we know how many operands does an opcode need? Let's say, okay, add needs 2 operands. So if we do find the opcode for add, we know the next 2. We'll see it's not necessarily the next 2 bytes either. Because if it's a big number, it could be 4 or 8 bytes. Well, 8 bytes. Yeah. Sorry, 4 or 8 slices of byte. I guess. What am I saying? I don't know, it's fucking early. I haven't had that much coffee. Something like that. It can be more than... Yeah. Maybe I'm thinking too much. So our first official practical act of coding in this book, we create a new package called code, blah, blah, blah. So we have 2 new types. One is for instructions and the other one is opcode. My guess is it's gonna have some methods on it. Let's keep going. Excuse me. Instructions is a slice of bytes and an opcode is a byte. Right. They match our descriptions in prose pretty well. But there are 2 definitions missing. First one is instruction, singular. Why didn't we define it here as a slice of byte? Okay. Well, oh, I think this is for the Go devs. Right, okay. It's far more handy to pass around implicitly an instruction. Right, yeah. You'll see soon enough how often we're going to use slice of byte and how cumbersome type assertions and type casting from and to an instruction type would be here if it were not a slice of byte. My guess. The other missing definition is one for bytecode. There should at least be some definition of bytecode that tells us it's made of instructions, right? The reason for this, for its absence, it's we'd run into a nasty import cycle if you were to define... Oh yeah, I remember this one. Now that we have the definitions for opcode and instructions, we can define our first opcode. Nice. One that tells the VM to push something onto the stack. And here's a surprise. The opcode won't have push in its name. In fact, it won't be solely. What a weird word. Solely. Why? But pushing things. Allow me to explain. Okay. We said earlier that when we compile the monkey expression 1 plus 2, we want to generate 3 different instructions. 2 of which tell the VM to push 1 and 2 onto the stack. My first instinct might tell us to implement these by defining a push instructions with an integer as its operand. The idea being that VM then takes the integer operand and pushes it onto the stack. And for integers, that would work fine because we could easily encode them and put them directly into bytecode. I read it, but I was not here. You know, if you catch my drift. Defining a push instructions with an integer as its operand, with the idea being and pushes it onto the stack. And for integers, that will work fine. It's also possible true. Yeah, I mean they're all bytes after all. Luckily, in Zig we don't have strings, so I don't need to worry about that at all. Wieldy. That's where the idea of constants come to play. Is short for constant expression. Alright, I remember this bit, because we would know them at compile time. Okay, maybe I get to use some comp time. I have used it once. No, I haven't. Tried to write a generic method in Zig. I failed. It wasn't generic, nor did it work. Right. After that, blah 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 blah. Alright. Can reference the constants in the instructions it generates. Hang on, what the fuck? We can reference the constants in the instructions it generates. Right, okay, yeah. Instead of embedding the values directly in them. Yeah. And while reference sounds like a special data type, it's far easier than that. I'm guessing it's just a stack pointer, or like Maybe, not sure. A plain integer does the job just fine and can serve as an index into a data structure that holds all constants, often called a constant pool. Right. Well, by pointer I meant a number that points to where it's located. That was pretty close. And that's exactly what our compiler is going to do. Oh, this is right in my wheelhouse. I do this all the time. I mean, mainly because I just don't like the array list standard library method. I'm not saying it's not good, just like I don't like using it for some reason. Feels like if I can't manage an array, what am I doing here? But that being said, I used it in the past, so I gave in. But before that, I was using an array. Yeah, so the constant pool, easy. Well, because of the word pool, I'm wondering if you need to keep track of the free space and then reuse it later. Maybe. When we come across an integer literal, a constant expression, while compiling, we'll evaluate it and keep track of resulting integer. I'm all over the place today. Completely not here. Okay. We come across an integer literal, a constant expression, while compiling. We'll evaluate it and keep track of, yes. Oh yeah, I haven't done evaluate, it's fine. By storing it in memory and assigning it a number. In the bytecode instructions, we'll refer to object pointer to pointer to integer by this number. Oh, interesting. You mean from the constant pool? Okay. Yeah, I'm not sure I get all of it. After we're done compiling and pass the instructions to the VM for execution, we also hand over the constants we found by putting them in a data structure. Excuse me. Our constant pool, where the number that has been assigned to each constant can be used as an index to retrieve it. Right, yeah. What if Oh no, okay. If we have the index, that means the pool. Well, the number in the pool still active, kinda. Okay. Back to our first opcode called op constant, and it has one operand, the number we previously assigned to the constant. What? It's called op constant and it has one operand, the number we previously assigned to the constant. Okay. I have no idea what that means. What constant? And where do we assign? Oh, maybe after? Okay, fuck it. When the VM executes op constant, it retrieves the constant using the operand as an index and pushes it back on the stack. Yeah. What the fuck? I don't think I get it at all. When the VM executes op constant, it retrieves the constant using the operand as an index. Oh, okay, so this is not the operand. Oh, okay, fuck's sakes. I was confused for a second. Right, okay. So this just keeps track of... I don't know what it keeps track of. Here's our first opcode definition. I have no idea what this is for yet. Maybe if I keep reading, it'll make more sense. Which makes no sense at all. Well, this looks exactly like the meager 3 lines of code that they are. This addition is the groundwork for all future opcode definitions. Okay. It's kind of like GoZenum. Minus type iota. Op constant opcode. Opcode is just a byte. Okay, each definition will have an op prefix. Okay. And the value it refers to will be determined by iota. Right, we let iota generate increasing byte values for us, because we just don't care about the actual values our opcodes represent. Yeah, because we only care about, so it's just an enum basically, like my tokens. Okay, that was a roundabout way of explaining that. They only need to be distinct from each other and fit 1 byte. Yeah. IOTA makes sure of that for us. Right, okay. Might not even need the opcode type, because in Zig, I can get the, I can use the enum, and then the enum type. Well, the enum will be the type. That makes sense, kinda. It'll make sense in a bit. Says yeah, what's missing from this definition is the part that says op constant has 1 operand. There's no technical reason for writing this down, since we could share this piece of knowledge implicitly between the compiler and the VM. What do you mean op constant has 1 operand? For debugging and testing purposes, though, it's handy being able to look up how many operands an opcode has and what its human readable name is. In order to achieve that, we'll add proper definition and some tooling to the code package. Excuse me, jeez. Wild. Okay, so we have type definition. Okay, so we just saved the name of it. It's not too bad. I guess there is not many. What does this mean? Operand widths, as in how many? I'll be honest, I'm like totally confused so far. I forgot what this fucking op constant was. I'm not forgot, like I'm not sure I understand what it is. Okay, I mean, this is straightforward. It's just a map. Excuse me. If you pass it a byte, it'll return you. Oh, you return the constant. Sorry, the definition. All of it. Okay. It's fine. Yeah, so the definition of op constant says that it's only one operand oh, you motherfucker. Now I get it. Why would it be 2 bytes? Which makes it an unsigned int 16 and limits the maximum value to 65,535 or a U16. If we include 0, the number of representable values is then one more. Fuck. Okay, I think I understand. It's just the index. And it's 2. Okay, it's a U16. Okay. It's not that bad. I get it now. Okay, and using U16 instead of, say, uint32. Right. Okay, the instructions are gonna be... Whoa, whoa, whoa. That last bit just threw me off a little bit. Right. It's those many, like 65,000 constants is what the compiler will compile like a max. Helps us keep the resulting instructions smaller. Not sure about this last bit. Because there are less unused bytes. Okay, we'll come back to that in a little bit. With this definition in place, we can now create our first bytecode instruction. Okay. Without any operands involved, that would be as simple as adding an opcode to an instructions slice. Yeah. But in case the op constant, we need to correctly encode the 2-byte operand. Okay. Not sure about this 2-byte operand. Okay. No. For that, we'll now create a function that allows us to easily create a single bytecode instruction that's made up of an opcode and an optional number of operands. We'll call it make. What the fuck is make again? Okay, let me read the previous one again. Without any operands involved, that would be as simple as adding an opcode to an instructions slice. Yeah, but in case of op constant, we need to correctly encode the 2-byte operand. You mean because the op constant, which is an index of sorts, is going to be 2 bytes long. Does that mean our pointers, in this case a number, is 2 bytes, a 16-bit pointer basically? I guess it does. Okay. In that case, maybe I get it. For that, we'll now create a function that allows us to easily create a single bytecode instruction that's made up of an opcode and an optional number of operands. We'll call it make. Well, I was thinking about the previous paragraph. I still don't know what make is. It will create a function that allows us to easily create a single bytecode instruction, right? That's made up of an opcode and an optional number of operands. Okay. Now I get it. We'll call it make, which gives us the identifier code.make and other packages, right? First test. Right, okay. What does make do? So it takes an opcode. Yeah. Which is an enum, basically. Operands. This is, I'm guessing this is our stack. Sort of, maybe, not sure. And we expect, these are the instructions that we expect. Okay, so we have the opcode here is op constant, which is, so far, if I understand, a pointer. Yeah. A pointer to where the constant is on the stack. Okay, and we have one 2-byte operand. That's 65534. What we expect? What do we expect? So our instruction should contain does this together make 65534? Oh yeah, because 255 is the biggest number in a U8. And I think this is too short of the maximum. Did he say 6536? Yeah. This is one. Okay. I think that kind of makes sense. 6553. I mean, this bit is fine. Not too concerned. Guess it might be easier to just use bytes, I guess. As in, yeah, like binary instead of decimal. Or maybe even, nah. Okay, fuck it, decimal's fine. It's not that big. Right, and then you call what would make returns an instruction. So it would take opcode and operands and return a single instruction. Or all the instructions. Not sure. Okay. I'm still a bit confused. Instruction is okay, so you pass it all the operands. It's weird because there's only one. Okay. Who would have known? Compilers would be complicated. Or maybe it's not complicated. It is simple. Or like Randy says, maybe I am the simple one. Yep, yeah. We'll be extending this later. We only pass op constant and the operand that to make. We then expect 3 bytes. Okay, I think I can kind of understand where he's going with this. Because each, what's it called? Opcode. Each opcode has a width associated with it. In the case of op constant, we know it's a U16, so it accepts. Okay. I think I can see where he's going. That's pretty cool. I just realized. So let's say we have add. I guess the width would be 4. Because each element in our stack would be 2 bytes. So that means it would have a width of 4. And push would also have a width of 4. Oh, I don't understand what this fucking op constant is. Okay. Okay, I guess I should let him cook. Don't be put off by, yeah, that's fine. For now, we only pass op constant and the operand 65,000, something. We then expect to get back a slice of byte, which are the instructions. And I guess we would append these instructions onto some existing set of instructions. That's cool. I can just... One moment I understood nothing, and now I can see where this is going. I fucking love this shit. Of these 3, the first one has to be opcode, op constant, and the other 2 should be the big endian encoding of 65. What is host endian? No, is host endian big or little? Endianness. Or does it depend? Yeah, let's have a look at this one. Host to network, network to host. Little endian places, yeah. I forget what order is network endian. What endian is network endian? Yeah. Network endianness is big endian, also known as network byte order. Okay, got another question. Does endianness vary on host? Yeah. For some reason, I always thought network endian was little endian. Turns out I was wrong. Not even close. And it's 50-50. Hey, I am me. That is you. You've been lurking. Lurkers are welcome. I don't mind lurkers. How you doing? So you know, I'm struggling. Kind of. I was, but now things are starting to make sense. Kinda. For now, we only pass up constant. The other two should be together, should be big endian of that number. That's also why we used 34 and not 35. This way we can check that the most significant byte comes first, right? Because the last, we need to know, okay. Most significant byte comes first, right? That's the byte sequence FF and FE. And if it was not big endian, it would be a much smaller number. Yeah, makes sense. Mm-hmm. Mm-hmm. Right, yeah. So make would get an opcode and some number of operands. I guess we could assert we have the right number of operands based on the width of this opcode. Yeah. So we look up. Well, we had a whole function for this. Didn't we? There was this lookup. Mm-hmm. Where did it go? Yeah. Anyway, can use the lookup. Yeah, and we can assert that the operands are at least as wide as expected. Instruction. Okay, there'll only be one instruction returned. What? Definition, yeah. Instructions plus equals W. Actually, that's another question. Why was it a slice of what was, oh yeah, it is a slice of int, because if you have more than one operand. Okay. Right. You add the width to the length of the instruction. So the length of the instruction, if I understand, is how many bytes in that case. You make a slice of byte of that long, yeah. So yeah, the first, what's it called, element, or yeah, first item would be the opcode itself, and then you range through then you would use the op constant to get so you go through the operands. Okay, because you accept an int. I guess it could be simplified. Why accept a slice of int? Why not just accept a uint16? Okay, hang on. I see some things that could be simplified. So you go through the operands, which are all numbers, let's say for now. But if you pass in a big number, where did it go? Yeah. The width is the expected operand width. There's going to be 2 in this case. Not sure what he's doing here. Kinda confused. Not gonna lie. We get the width, which is operand width of I. So the first one. The first one will have a width of 2, because that's what we have for the op constant. Then we put a uint16 to instruction. The offset is 1 from what the fuck. Oh yeah, the offset is 1 because we've already added the opcode. Yeah. So if we consider 65,000, that is a single operand. So this range would only go through once. Okay, hang on. I gotta check. Package.go.dev binary. Oh, I wonder if it splits the int and then spreads it accordingly. Big endian. Let's big endian. Maybe I can just check. Put UN16. Where is it? Make slice a byte of 4 length 4. Okay, gotcha. Cause 3E8. My guess is this is a 16-bit number. Okay, I think I get it now. What this method does is, right, because this is a slicer byte, we're converting this operand into UN16 and then boom, it just puts it into the slicer byte. Okay. Offset plus equals width. Right. Okay, yeah, that makes sense. Return instruction. Okay, that's how you make bytecode. Took me a while, but I guess I do get it. The first thing we're going to do here is to find out how long the resulting instruction is going to be. That allows us to allocate a byte slice with the proper length. And that we don't use lookup function to get the definition. Yeah, I was thinking the same. Which gives us a much more usable function signature for make in the tests later on. Oh, okay, because you don't want to return errors. Instructions without having to... Okay, I guess I kind of have an idea. Code.seg. So what we got to do is we have opcodes, which is an enum, and they're all bytes, byte size. Then we need a way to look up the opcode and see how many operands they need. And once we have this, we need a make that would return instructions. That's not too bad at all. Which are nothing but slice of bytes. Okay, so what I can do is I'll use the array list thingy and then go from there. Maybe. Okay. Not sure if I need a type for instructions yet. Yeah, I can have a look at that later. So we'll have const op code, which is an enum of byte. Have op constant is the first byte. Constant. I think this is nothing but a pointer to the stack. Okay. That is one problem. Yeah, just one. Maybe there isn't. I'm not sure if I can. I guess I can, yeah. So I need a map, sort of. What I need is to be able to look up opcode and see, and I should be able to see width of operand and how many, and a human readable string for later debugging. Okay. I do need const. What's I think it's called? You call it definition. Will be a struct and call it name. So it'll just be a const u8 and then need a width. The width here is going to be I don't think it needs to be an int because they're like tiny numbers. Let's call it, I think they can be slice of byte. Or even smaller. Okay, so we can now forget how to use maps. I may have a look at my parser. I did use a map here. Oops. Map, hash map. Yep, there we go. Where is it defined? Right. Got a okay. I think if I look in new, there we go. I need an allocator. So maybe an auto hash map. Probably not the best. Okay, so what do I need again? Oh, I see. Parser. Need the REPL Lexa token. No. Okay. Maybe I can just have it. Excuse me. As a method here. Like lookup. Let me check documentation. I think you can have methods there. Did I specify? Yeah, I did. Type. Yeah, here. Okay, so what I can do is yeah, okay. I think I got it. A public method. I call it lookup definition. We'll take an opcode, which is an opcode. I'll return type. What's a type? Hang on. How do you define errors? Okay, easy. So const code error will be an error and then invalid opcode. What's that now? Okay, yeah, I'm not done yet. So this can be an opcode error or a definition. Okay, that looks good. That looks good. So we switch. I forgot how to use switch. Oh, this one right here. Oh, actually we'll add much earlier because I expect an opcode. Oh, beautiful. That can never happen. Nice. So I can do return switch code. Okay. So if it is op dot op constant, damn, I can't remember Swift syntax at all. Okay, it's an error. Then I want to return definition dot name will be op constant, yeah, and then dot width will be I don't know if I can do that. Can I do that? I don't think so. Well, anyway. Let me have a look. Slice. Okay, actually this can be const because not gonna change. Excuse me. Maybe I can do the same. Well, how does it go again? Okay, easy. And dot. Slice of const G4. Okay, that's the lookup sorted. I guess now we can write make takes opcode and operands, which is, I think they're all, actually we can't, well, I'll just take, I'll accept U16. Don't know if I can do the spread. Slice have seen it somewhere. I don't remember where. Add a list. It's a good question. I've never looked it up. No, you can do that, but what's it? It's called Zig Guide. No. Oh, hang on. What am I doing? Should be here. Guess it doesn't matter. What I'll do is let's do a const 16 for now. Okay. So int and go is 32 or 64, so I'll make it 64. And then it'll return slice of U8. Okay, maybe it can be slice of const. Leave it as U8 for now. Okay, so first thing I need is width. Is going to be opcode dot lookup definition. For can this be self? Let me check. In where's the switch example? Okay, yeah. So I can switch self. So this is opcode dot up constant. Can't be anything else now. Maybe I'll also make this, rename that to opcode. It's better. Can differentiate it easier. Okay. Definition dot width. Guess this will never be changed. Okay, perfect. Right. Now we need to go through the operands. Operands. Oh, hang on. We got to add the opcode. Oh, actually, yeah, I think that should work. Our instruction is an array. How big should it be? End of operands. Oh, it's not. Operands. Operands dot. No, fuck. Hang on. We have opcode. Oh, and then the width. Okay, that makes sense. And let's call this var instructions len will be equal to 0. Oh no, this will be equal to 1. What am I doing? I'm getting confused. Okay, let me write this down. Find out how long, how many items in the instruction array. And we can find this out by, so opcode plus width. Right, and then append code, then whatever. Okay, so I can do this by for width. Okay, can't fucking type. We need our instruction size. Equal 1. We'll say 1 for the opcode. This would be instruction size plus equal W. Okay. And then we can have instruction going to be I haven't written Zig for 2 days. I can't remember half the shit. Arrays. Okay, there we go. Just do instruction size. Might not work because it probably needs to be a U size. U8 equals undefined now. So instruction of 0 is going to be opcode. Op. And I guess we don't need this. For all the operands. Need to switch. So what am I doing here? And each operand to the instruction. I guess based on the width of the operand expected. So we do switch width. Gotta do. So if it's say 2, right? So maybe the standard library has something big and binary. Maybe N to H. Mostly for Windows. What about the rest? Endian. No, nothing. I guess we're gonna do this ourselves. Okay. I'm gonna cheat. I'm gonna check how they did it in Go. Put 16. Where's the definition? Big endian. Big endian. Kind of want to do the opposite of this. Map file. I've been trying to convert 2-slice const-u8 into an i16. Standard mem Read big. What was it called? Read int. Read int. Reads an integer from memory with bit count specified by t. The bit count of t must be evenly divisible by 8. This function cannot fail and cannot cause undefined behavior. So I kind of need to do the opposite. I need to convert the operand, which is a 64-bit integer, well, 64-bit something, not necessarily. Well, yeah, 64-bit number. The fuck am I saying? So I need to convert it to a U16. No, yeah, I do. Yeah. Because the width is 2. Convert to a U16. And then and each to a slice of U8. Easy peasy. Lemon squeezy. Excuse me. Okay, I can read into a U8. Not sure what's actually happening here. We didn't. Yeah, we're trying to read a U16. Buffer. Div exact type of. Okay, actually, I think I just figured out. I got it. Const standard equals imported. I'll get mem2. What the hell? Dot mem. Okay, so this is going to be mem dot read int. So I need to read U16. How do I actually pass the number? I don't think that's it. So it returns a T I want to do the opposite of that. Okay, think I know what to do. We're gonna ask GPT, how can I do the opposite of this in Zig? Read a U16. No. Save a, well, get two weights from a single U16. And in the meantime, hang on, so this can be smaller, but it only returns T. I need more than one T. See what else we got. Factant. Turns the largest slice in the given bytes that conforms to the new alignment. Align in slice. Align pointer as bytes. Big to native. Byte swap fields. Bytes to value. Last index of blah blah. Hang on. There's a simpler way to do this. Let's say there is no method. I know that the width is 2. So why don't I just grab something like that and that. Yeah, guess that's an option. Let me see what GPT says. Do the opposite, extracting 2UF, you can use bit shifting. Oh yeah, actually. I can do that too. So to get the first number, I can just shift it 8. That would give me the first number. Shift right, yeah. And then if I shifted left 8. That will give me the second number. And then, well, I don't need to hand anything. Okay. Oh, okay, and I cast it to a U8. This seems like a simpler way to do this though. I mean, it's quite simple. Yeah, and low byte is if I right shift 8, I get the first number, and to get the second, why this is not correct though. Oh fuck, okay, value. Yeah. Oh no, I can't left shift 8 because it'll become 0. It'll be old 0. Yeah. Yeah, I guess this could work. Because this is FF is one number. Hang on. Let me do binary to hex. So if I have 1, 2, 3, 4, 5, 6, 7, 8, that is FF. What if I had 3, 4, 5, 6, 7, 8? Okay. Yeah. Yeah. So what I'm gonna do is get rid of maybe this one too. Need a block. Our high byte will be a U8. Let me have a look at int cast. I think it's somewhere here. Converts an integer to another while keeping the same numerical value. Cast. And then what I'm doing is operand right shifted 8 times. It's the high byte. And then I need low. Also be this one is just an AND. FF. Okay, so I need to keep track of index for instruction index equal to 1. Then instruction of an index equal to high byte index plus equals 1. Okay, and then this will be load byte. I mean, it's not very pretty, but I guess it does the job. I right shift it, and I should get the first byte. Okay. I guess that's it. I think I might need an else. Unreachable for now. We'll handle the errors later. Test make. What tests? Hang on, I'll just copy my other tests. Saves me some typing. Make instructions method. Guess I don't need any of this. Expected. Opcode. Operand. And then expected value. I guess this would be const u8 as well. Might not be a const, not sure. Only need one. Opcode is opcode dot op constant operand no, operand's gonna be not a const. 64. It's going to be 65 6 3 335. Is that the biggest number? I don't remember. 65 534. Not even close. 534. And then I expect to. Actually, it's also not const, it's just numbers. Expected bytes. Oops. It's going to be do the same. Oops. Where's and here? 255. Because they're all 1. Then 254. What should be the length of instruction? Mhm. Guess I could add one more. Expected width. This is going to be a number. Dot expected width to be 3. And I need a cert. Cert is standard dot testing dot assert. Yep. Cert. Okay, hang on. Can do what am I doing? It's actually much simpler. Expect okay, this has to be in here. Tests of I dot opcode dot lookup. I know. I'm just making my life too hard for myself. Assert. So it's 1 plus and expected bytes dot len equals instructions. Oh, I gotta call make. Const instruction is equal to make tests of I dot opcode and tests of I dot operand. It does not error instruction dot len. Okay. We don't have this anymore. Tests. Guess we don't even need that. Oops. Don't need that. Don't need that. This will be test. T. Make t dot opcode comma t dot operand. Yeah. And then we can check testing testing dot expect equal Okay, for, we just go through the instruction. Instruction. There must be another way to do it. Check if opcode operand match expected. Okay. To check the first one, I can do cert t dot opcode is equal to instruction of 0. Okay. And then instruction comma 1. Grab the index, then testing dot expect equal okay, it's const testing standard dot testing. Expected, any type, and actual. Try. What am I expecting again? Hang on. Guess I could go the other way around. Expected t dot expected bytes, and then this would go from 0. B. Byte should equal instruction of I plus 1. It's kind of ugly, but I guess all there is to do is sig test source slash code. Yep. Expected slice of const2 found code dot opcode. Yep, I think the type is wrong. This should be opcode. Expected slice of U64 found pointed to 1. That is a good question. Good point. Okay, let me check. Slice should be here. location. What are the ways I can declare a slice without having to create an array? No, these are mostly strings. Okay, I guess it's another question for GPT. Hang on, Inish, it's a guide. Where is it? Guide. I think they had some examples. Yeah, I'm gonna ask. Cloud. In Zig, can I declare a slice of for without creating an array? This does not work. What was the error again? Expected a slice of U64 but found a pointer to a const array. What if instead just made this a const? Okay, that would work. That works for me. Expected width. Yeah, I don't need that anymore. Assert is not. Am I using the wrong method? Oh, it's debug.assert. Yeah, it's marked public. Okay. CompTime int must be a const or CompTime. Yikes. I guess most of these are CompTime. Okay, so what if... Hang on. That means I gotta look up comp time. Comp time. At the call side, the value must be known at compile time, or is it it's a compile error? How do I say something as comp time? Can I do this? That looks wrong. Comp time int. Concept whether the expression is known at compile time. At a few different places, this concept is used. These building blocks are used to keep the language small, readable, and powerful. Introducing the compile time concept. Comp time parameters. Can't be a const because I need it. I need to update it. Time. Really? No. Is that correct? Let me have a look at the other errors. To modify this variable at runtime must be given explicit I can fix that. Because I can cast enum to something something. That one's fine. I'm not bothered. This one, motherfucker. Okay, to do problem for tomorrow. Comp time thingy error. Okay, I mean it's not great. Tests are not passing, but I can do that tomorrow. Yeah, I guess I'm gonna call it today at comp time. Yeah, I guess I'll see you tomorrow. Yeah, as always, have a good day, and I shall see you later. See ya.